Good day everyone, Regan Korea. This lab is Port Swingers Web Security Academy lab and it's Spot Doom XSS. Right? There's something I've observed. Port Swinger explained Spot Doom XSS in terms of writing alone, right? But you have to do extra work to figure out why they use this payload for this solution. If you observe, the payload most times they use for reflected XSS will be quite different from the payload Port Swinger will use for stored XSS, right? And also to be quite different from the payload that Port Swinger will use for stored DOM and reflected DOM, right? Now the question is, how did they come about this payload? Right? Most beginners or pen testers, right, we will just want to copy the payload from the solution, from this solution, right? You can see we just want to copy this payload from this solution and then paste it on the vulnerable search box or the vulnerable comments, right, and just move on to the next lab. But in the real sense, that's not how it's done, because in a real pen test environment, you have to follow the due process and just putting it inside the box and moving on to the next lab, right? So in this lab, I'm going to explain to you guys in details how Port Swingers Web Security Academy came about this payload, right? You see it live. I won't guess it, right? I will follow the due process in terms of the enumeration and the pen testers method of exploitation. So we're not just guessing payloads, we will see it in the process of doing our penetration testing on this vulnerable lab. Okay, so without further ado, let's start this class. So the first thing we'll do, I've solved this lab already, but let's see if I'll refresh it. Alright, so let's see, we'll get alright, so this is the lab. This has been solved already, but let's take it again and I'll show you exactly how this payload came about. It's in a real pen test environment, right? Pen testers have to follow due process to come about this payload, and not just guessing. We do our exploitation. After our exploitation, then we discover, naturally from our exploitation, we discover the payloads that we use for the attack, right? So now the lab says, this is the lab. It says this lab could demonstrate a stored DOM vulnerability in the blocks comment functionality. To solve this lab, exploit this vulnerability to call the alert function. Now, the clue that Port Swinger gave us is Port Swinger said there's a vulnerability in the blog comment functionality. But in a real world scenario, in a real world environment, right? So the only thing we're doing, we're looking at the real world environment, we're not just doing anything just like that. So in a real world environment, this clue will not be given to you, right? You have to figure it out by yourself with black box testing. So without any clue, without any information from anybody, right? So in a real environment, will not be given to us, block comment section. But you should know that when we are dealing with stored doom SSS, right? From the word stored doom SSS, the attackers target vulnerable sections like the comment sections, right? They target anything that involves input, right? Because once you input your data, two things are involved, right? It fetches your data and it reads your data. So the attacker use the malicious JavaScript and put it in that section, right? So once you input anything, probably your username and password or any vital information, it fetches your data for the attacker and it reads your data. And once it reads your data, the attacker will also be able to read it from his own end, right? So that is the basic purpose of stored, right? Now, when you now combine stored doom, right, after the fetching of data and the reading of data have taken place, right, there's also the vulnerability is also in the JavaScript of the browser. So these two connections bring about stored doom SSS, right? That is how this came about, stored doom SSS. So now, to solve this lab, exploit this vulnerability to call the alert function. You should also note that this alert in a real environment, or an attacker won't use alert. An attacker will place this alert with a vulnerable and a dangerous JavaScript, right, to steal sensitive information. So we go to the lab. So this is the lab. Let's refresh. So we know the purpose of what we are doing right now, to know where those payloads came about, where those port swingers payload came about. So it says in the blog comment section. So let's go. This is the blog itself. The first thing a pen tester will do is web mapping, web application mapping. So if you are running from a black box testing, we have to click this, right? This could be vulnerable to SQL injection, conditional error, conditional response, because of the tracking ID that will be reflected in the HTTP request. So in a real pen test environment, pen testers should map this application from beginning to the end, right? So you click and click. The main goal is just to click this, click that, click, map it, click vital places, right? Like this hole is very vital for SQL injection, right? Now, back to our topic of discussion. So we'll go to view post. Go down. They have given us a clue already. So comment section. So now stored doom SSS, right? For stored doom SSS, this stored doom, or rather for stored SSS. Once you make a comment here, right, to confirm a stored SSS, you create a comment here, right, and you are logged in a site. You create a comment here, you log out, right, and log in again. If you still see that same comment after you log out for some time and log in back. So what are we saying? This is the practical aspect now. Let's say we do stored doom 1, 2, 3. Let's just use any name on any website. Now click post comment. Thank you for your comment. Your comment has been submitted. So let's go back and refresh. So we want to see our comment here. We want to see our comment here and see Regan.Doom. Regan.Doom 123. Now, how do we confirm the stored Doom XSS? Sorry, how do we confirm the stored XSS before we go into stored Doom? As you can see, I'm logged in. This is my profile. So what I'll do is that I'll log out and log in back again. I don't want to do it right here, but if you are doing yours, you do it. I've done mine already when I was solving this exercise, so I don't want to log back out and log back in again. So you log out, wait for some time, then log in back and come back to this same page with this you take note of the photo, right, of the blog. Log out, log in back, then you should see your comments here. So it will confirm by stored XSS. Now, after we confirm that it's stored XSS, we now confirm that it's stored Doom. So we have to confirm the Doom aspect. So how do we confirm the Doom aspect? When we are dealing with stored Doom, your input or your payload, right? In this case, this is my input. Your input should be in the Doom, right? Doom means document object model. Your input should be found in the Doom when you inspect it. This input should be found in the Doom for stored Doom XSS, right? So two things I've mentioned here. Once you log out, you log in back, you should see your comments that confirm stored. To confirm the Doom, your input, this input will be found in the Doom when you inspect it. So let's inspect this now. So we will inspect it. We'll go to the JavaScript of this port swingers page itself. Just go to the JavaScript. So go to the drop down, CJS, drop down and load comment. So this is the JavaScript. So let's just this post ID, this page itself, post ID 8, which is same as this top here, post ID 8. So we just add it to. So we have two things that were added here. We have the JavaScript and the post ID 8, right? So we're going to do universal search. We're going to do universal search. Sorry. So we're going to do universal search right now, and we're going to be searching for our input to confirm that it's stored is in the Doom, right? It's in the document object model. So before that, we are going to refresh our page. We're going to refresh this page. So we'll do cap lock. On your cap lock, then do Control R. Now you find your input. Your input is stored. I don't know if that is capital letter or small letter. It's stored Doom 123. I think so. Right now, yeah. You can see stored Doom 123. So my input is found in the Doom. So with this few investigations of mine, I'll be able to confirm that this is the stored Doom not SSS rather, not yet. This is stored DOM. It's not yet an SSS, not yet a cross-site scripting yet. We have not yet confirmed that it's a cross-site scripting, but we have confirmed that it's stored DOM. So now what next? The next flow is to confirm that it is stored in cross-site scripting. So that will now be confirming the stored DOM cross-site scripting. In the real world is stored document object model cross-site scripting. Now, next step we'll do is that, in our previous video we used sources like location.search, location.hash, document.referrals. We use different kind of source related to those words, right? But in this exercise we are dealing with stored, and when we're talking about stored, we're talking about gathering data and reading data. The attackers is gathering the data and reading the data. Let me give you a typical example of stored SSS, right? The normal stored SSS, not the normal stored SSS. So a typical example of stored SSS is if you enter a website, right, and you just see a form, a beautiful form. If the website is vulnerable to stored SSS, you see a beautiful form, and the form just looks innocent, right? You don't know anything that's inside the form. You're not seeing what's the malicious words and everything that have been positioned inside that form, right? The form is just there, beautiful and innocent, and you decided to input your vital information in that form. The form could have a Facebook logo, right? A exact Facebook logo with username, password, but you'll be thinking probably it's Facebook. More like you enter the website and you want to redirect it, tell you to redirect to Facebook for you to see or do one or two things about the website. Then you think that it's a real Facebook account and you decide to input your username and password because you saw the Facebook logo and everything, very beautiful form, right? And you input your username and password, and boom, that process alone has fetched your data and have read your data. So the attacker have fetched your data and read your data. So that's how we call it stored SSS, right? And we have done some practicals here in terms of stored SSS. Why we call it stored SSS? Now, I made mention of two things. I made mention of fetching of data and reading of data. This has nothing to do with location.search, location.hash, any other thing. It has nothing to do with it because in stored we're talking about storage. So the sources we will be focusing on are not location.search, location.hash. Instead we're focusing on sources like local storage. So we're focusing on looking for sources like local storage, right? Not found. So we're focusing on sources like fetch, because it fetches data. So we're focusing on sources like fetch. Let's see fetch. Sorry. Let's see fetch. Focusing on sources like, these are sources, right? We're not using the normal location of search and stuff like that. So we'll focus on sources like XML, HTTP request, XML, HTTP request. I think it's sensitive as well. Alright, so This word alone in this search, right? We finding this word in this search after we have done our findings, our basic pen testing for stored doom, not stored doom SSS. Now stored doom alone, but confirm that it's stored doom, not stored doom SSS. And we now see this in our search box for the source. Then you leave a 100% confirmation that your stored doom finding is confirmed, right? So what you found that is stored doom, your stored doom findings is confirmed. So now this is a source. We'll click it. Now this is where it gets interesting. Before you can use a payload for exploitation, in this case, stored doom SSS exploitation, before you can use a code, pen testers don't just guess codes. We carry out all this process, right, step by step. Carry out all these processes, right, step by step, all the way. And our main goal during this process is to get the source and to get the sink. To know the source and to know the sink. We have known the source because this is the source, right, for stored doom SSS, XML HTTP request. Now our main goal is to get the sink. But once we get the source and we get the sink, then we can know our payload. In a real environment and in various labs, sources and sink differs. You might be doing another pen testing for stored doom, and the source might be fetch, and the sink might be outer HTML or maybe inner HTML or stuff like that, right? And it differs, so that's why you have to. And anyone that as they differs, right? As they differ, so as their payload also differs, right? So you have to know the source, and we have to know the sink, and we know the payload. So this is our source, right? And we know how we got to this point, to this source. We know how we got to this source. So we click this source. So this is where it's located, right? So our goal is to trace user input from the source, which is on this source, to the sink. Now, how do we do it? We use breakpoints. We call breakpoint. This is breakpoint. If you click the number, any of the numbers, you click it, especially the number that contains the source. In this case, the source is XML HTTP request. So we click 2, which contains the source, right? This is breakpoint. Performing this action alone, you have performed breakpoint, right? This is the first step to tracing user input from the source to the sink. Now, the second step is to understand step over, step into flow. In this point here, right? This is step over, this step into. Let me on it, right? So after you set your breakpoint, what you do is to on your cap lock and press Ctrl R for this to activate, for these things to activate. So it will pause the debugger. Once you do that, the debugger will be paused, and we'll be able to use these features. And I'll tell you why breakpoints. The use of breakpoints, why do we breakpoints and all the stuff. So let's breakpoint now. So your cap lock, then Ctrl R. Now you can see this was paused. This was not activated before, but now it's activated. As you can see from the left hand side, pause in debugger. So now, what does it mean? We're not doing all these things blindly. we understand the flow, we understand what it means and why we're doing it. So now we pause that two. The two is where our source is located, right? Now what does this mean? It means that when the code run all the way to this point that we put our breakpoint, right? The debugger is going to stop, right, and give us the opportunity to assess what's going on inside this code, right, inside this function rather. So the main goal of putting this breakpoint is to make the overall code pause at this point. Then we'll be able to assess and trace whatever we want to trace and do whatever we want to do. Right now, the code ran all the way to this point. Now it paused, and here is our features that we'll be using to navigate through this code. Very important. We have to know how to use the step over, this step into, this step out, right? So these are the three important, especially these two, very important, and this important as well, but not as important as the step over and step into. Now, for you to know how to use or when to use step over, because it's very vital to know when to use it, when to use step over and when to use step into, you need to know the origin of your exploitation. What is the origin of my exploitation? The origin of my exploitation is comments, right? I saw my exploitation, you need to know the origin of your vulnerability. Before you know how to use step over, step into, you need to know the origin of your vulnerability. So what is the origin? So the question is, what is the origin of what I'm doing in total? What is the origin of my vulnerability? Why did I inspect? Why did I open this inspect? Why am I doing all these things? Because I found a vulnerable input in the comments, right? In the comments, that comment, right? The comment contains a stored DOM. We have not yet confirmed that it's stored DOM XSS. That's what we're doing. But the comment contains a stored DOM, and it revolves around the word comment. Take note. So take note of that comment. So anytime we see anything like logic that doesn't contain user input, we step over. Logic like if, logic like if, because let is more like more like storing a variable that contains the scripts, right, or the function. So we step over when we see logic or anything that is not related to or cannot give us any information about comments. Anything that cannot give us any useful information about comment or lead us to any useful information about comment that will lead to the sync. Remember, we're tracing input from source to sync. So we are observing the input. So in this case, the input is comments. Anything related to comments is an input. Any input related to comments, we want to trace it to see if it will land us in the sync, right? If you land us in the sync, then we have confirmed a stored DOM XSS, right? So we want to step over. What is step over? If any logic statement, if, right, or any script or any statement that is not going to give us any vital information about the word comments, right? Because our origin of our vulnerability is comments, right? So now we step over, starting from here, you step over, right? This is more like this is a function you can see from here. This is a function. The function name is load comment, and the argument is post comment path, right? So this xhr is a variable it was used to store new XML HTTP request. This HTTP request um, produces data, right? More like fetches data. Either HTTP request, web developers use either HTML HTTP request or the fetch itself, right? But in this case, both of them perform the same function, so they fetch data. And when you see something like this and you have confirmed your stored DOM from the initial process was done, and we see something like this, you know that your stored DOM is 100% confirmed. Stored DOM member, not stored SSS. Now, we step over this because it's not actually giving us any vital information about user input. It just tells us that we have confirmed our stored DOM with all our process that we have done earlier. So we step over. You can see it steps over to the next function. So this is more like a function flow. This is the original way where the source that we breakpoint, right? So the flow of this source is what it's telling us. It's showing us the flow, how it's flowing. So we're tracing it now to the sink, whether it's going to lead us to any sink. And we have to take note of the word comments because that is the source of our vulnerability. So step over. So I stepped over this, went all the way to this. So let's make it a little wider because we need to see everything that's going on. Alright, so you can see here is the source too, locations of search, but it's a source that is not really important to us because we're dealing with stored and not reflected or anything, and not reflected, right? We're dealing with stored SSS. You don't have any relationship with local locations of search in most cases, right? So, but there's a link to show that we are in the right path, right? Because this is the source and this is the source, or this is the main source for this stored SSS, right? Now, we step over this because let's say whether it's giving us anything important. It's not giving us anything important relating to user inputs, right? We are observing the comments and we're observing strings, right? Because the strings, where strings are present, where probably user inputs will likely happen, and where attackers can put in malicious JavaScript. So we step over this. This is send. So there's nothing going on here. There's no vital information about user input or comment or anything like that. So take note again, the sync we're tracing, there are different kind of sync. Dangerous sync. We have the inner HTML, we have the outer HTML, we have the document and write. We have different kind of sync, right? Very important. You have to know them. Yeah, I think they're up to like 7. There are up to like 7 vital ones that you need to know, but you don't need to cram it, right? You just need to document it, then just know it anytime you're doing any so you just need to document it. You just need to keep it in mind so that anytime you're doing pen testing or exploitation, then you will just bring it out and know that okay, you're focusing on this sync, this sync that will come up during your web exploitation. Now this will step over, no vital information. This is the curly bracket. This is the curly bracket. So we step over. Now, this is a script with our keywords or our main point of interest. Load comments, and you can see inside this load comment there is a string, and the string contains post comments, right? So this is a JavaScript, as you can see. It's wrapped with the word script, and there's a string inside. So it could be that attackers can put in something very malicious inside here. So it's something that is of vital interest to we pen testers. So we want to see if there's any connection between this source and the sink, the dangerous sink. Because if the connection between the source and the dangerous sink, then attackers can likely input malicious JavaScript inside this and steal sensitive data from the website owners and maybe other dangerous things in the web application. So we'll step into. So this way we will not step over. Because we don't want to step over this because it's a very vital information that we need to look into and see what is happening inside. So we have to step in. So we'll step in here. So this is a function, right? And this is a conditional statement, right? But this function is not leading us to anything concerning our point of interest, which is comments and maybe strings. So we'll step over. Use the curly bracket to step over, no vital information. Back to our conditional statement, step over. Back to our curly bracket, step over. Back again, step over. Okay. So we have a variable here called comment, and this comment is storing the JSON pass, and there's a argument inside we call this dot response text. I think this will hide data. This will hide data or something like that. So the text here will be hidden, something like that. I think so. But this is JSON.class is encrypted data, right? But it's not really that important, right? It could lead us to something very, very interesting if we step in. But if you look at it, it's more like a full function, right? It's present inside this function itself, both comments, and it's more like something that, looking at it, doesn't even contain a string, no string attached, nothing. So no user inputs can happen here in the real sense. So, but it's a vital information to know that okay, JSON.gas is here with this comment and stuff like that. So we're just hoping that if we step over, it will lead us to something very interesting, and because it's the tinted data would lead you to something very interesting. So we'll step over and see. And yeah, you can see here we have display comment, and inside the box we have comments. So from the script, from the function itself, this function, according to this function is called load comment from this top, and there's a conditional statement here, and if this conditional statement is true, then this is going to execute, right? And when this executes, display comment is going to actually happen around this point here. So it's very interesting to know what's going to happen around this point. So we can't step over it, you have to step in to see probably if it's going to lead, probably if it displays comment and if it's going to lead to a dangerous thing, because once it displays comment and it is attached or is tracing to a dangerous thing, then attackers can steal sensitive information, and you take advantage of that doom XSS and steal sensitive information. So I need to step in. Alright, so yeah, this is user comment, right? So there's an input, there's an input here, this is a string, right? So the input can happen here. This is very vital information that you need to step in to look at what's happening inside. So we step in. This is logic. This is logic, so we don't need logic for anything. Not really important to us. Basically, the general rule of thumb is just step over logics in Doom XSS. So not need to do anything. It's not connected to any of your keywords vulnerability. Step over. Alright, so you can see these are our keyword again. Vulnerability keyword comment, and this is more like storing comments, right? And this is more like an array, and inside the array we have the capital letter I, right? So this array is more like, if you compare it with Python. In Python we call it list, and array in JavaScript we call it array, but they do the same work, right? They store vital info inside here. You can use this. You can use the info that is stored inside here to do to execute or to probably run a conditional statement. So because of the keywords that we are focusing on, which is comment, because this comment is tied to this comment inside here, probably this comment is a variable and is tied to this, and this can be executed too, or can be called in the conditional statement. So we have to check what's going on inside. So we're here now. This is a comment section, right? And we have document dot create element blah blah blah, and see section string. So there could be an input waiting for attackers to put inside here and do their thing. So we have to step inside to see what's happening inside there. So same, yes, comment attribute class comments, right? This comment is a string, right? And some things can happen here too. Input can take place here, so we step in. So that is basically how we do it. We keep stepping in, and take note. In a real world environment, if the JavaScript is bogus, if it's much, if it's plenty, or if the source is too much, if the source is numerous, right? Or like we have different sources. If we have XML, HTTP requests, we have fetch, we have local storage, all filled around here, right? We do the manual testing as usual. Well, we will not be lazy about it. Then we keep the data we found. We do our manual testing, keep the data we found, and after that, we are going to use the DOM invader, right? We use the DOM invader to do all these things. Basically, this is what the DOM invader is going to do. What we are doing, what I'm actually doing right here, is what the DOM invader is going to do. But you don't just blindly use the DOM invader. You have to do the manual work by yourself. You have to do the hard work by yourself. And once you have done the hard work, then you use the DOM invader to compare your results, right? Because sometimes you might find maybe let's talk in terms of numbers now. You might find like five, probably five outside the scope of what we're doing right now. Probably you might find like 5 vulnerabilities, and the DOM invader might find like 2 vulnerabilities. So in that case, your manual testing was not pointless, right? So most times you might find 2 vulnerability, and the DOM invader might find like 2 too. So to confirm what you did is right. So just for confirmation, so you need to do your manual testing. Don't say because of you have a DOM invader you stop doing it, you not do your manual testing. That's the lazy man's job, right? And we pen testers are not lazy. So we step. So this first P element document.element. There's nothing related to comments here. This is a string, but it doesn't relate to comments, so we don't need it. So we step over this avatar element document blah blah blah. No comment, nothing. We step over this avatar element set attribute class. Is a string here, but there is nothing related to elements. Sorry, there's nothing related to anything related to comments, because remember our initial input vector was comments. So we have to be stepping into anything relating to comment to see if it will lead us to dangerous thing. So stepping into this is just pointless. So we step over this avatar element set attributes and this blah blah blah. So we step over. Okay, let's see what's happening here. I can't move, but I don't think there's anything. Even if this comment is not a string, so attackers cannot input anything inside there. So we just step over this. So comment.auto step over, nothing interesting to us. This is more like a conditional statement. So same here, you step over, no string, just a conditional statement. And boom, our sync. Right, so now we have successfully traced our input from the source to the sink, right? So you will notice during our trace, right, we were focusing on our key point vulnerability, which is comment, right? Because that is where we input our vector, our payload, right? So during the tracing, we were putting that in mind. So anywhere we see comment vulnerable and comment where the user inputs in terms of strings, right? We step in to see what's going on there. So we did that, which I said do Invada and do that too, but you still need to do the manual test and compare your result to do Invada. So we step and we step and we step out, we step into, and we landed in inner HTML, which is our sync. So it means that our comments, right, our input can be linked from the source to the dangerous sync. So basically it's vulnerable to stored to XSS. Now this is the point where we say it's now vulnerable to stored to XSS, right? So because of this overall flow. So now what is this information going to help us do? It's going to help us generate and know the payload to use for this exploitation. So how do we do that? The first thing I said, we need to know the source, we need to know the sync, that we know the payload. Now what is the source? The source is XML HTTP request. And what is the sync? The sync is inner HTML, right? This XML HTTP request linked, we traced our input from this source to this sync. So this is our source and this is our sync. So without cramming, what we do, we just go to next browser and we just type in XML, the source first, HTTP request, HTTP request. So we put our hyphen. This hyphen means to. Then we put our sync inner HTML. So source to sync payload for vulnerability. What is vulnerability? Stored doom XSS. Quick search. So let's see what comes out. Let's see. So we see, we don't cram, we just show you how they got those, how Postfinger got those payloads. Let's see. How do I go inside there?
Alright guys, so I switched to phone browser because my desktop browser is not giving me what I want. right? So after doing your vulnerability search and you have discovered the source and the sink, right? Because through the source and the sink, you'll be able to know the payload you use for your exploitation. So it's preferable to use the browser, to your phone browser, to search for the payload instead of your Chrome browser. Personally, that is my own preference. So it's easier and faster, right? Even if the search result gives me like 2 to 3 payloads, I can just try it and I know that one will work instead of guessing payload and guessing payload with using hundreds or maybe using like 10 payloads and 20 payloads just to guess without doing your proper findings about that kind of vulnerability. So right now we're going to search for, so this is our source, http requests to, so our sink HTML, inner HTML, right? So then our vulnerability is, so payload for our vulnerability is stored doom XSS. So we'll search now. Let's see what comes up. This is the best in terms of looking for, right? So you can see right here now, you can see that it's similar with Podswinger's payload, right? So if you go down, this is the first payload. Even if it gives you like 3 or 4 payloads, at least you can just try, but one must work, right? So instead of just guessing payload without getting, maybe having any clue at all, right? This method will just narrow it down to like 2 to 3 payloads. This is 1 here, and this is 2, and this is 3. So one of it must work, and the first recommended one that was given was this, and which is the same payload that Podswingers Academy used, right? So that is the way to get your payload without cramming, without guessing. You do proper workflow, and at the end of the day you will get your findings smooth and swift, right? So guys, that is all for now. We'll see on our next video. Thanks.